generation system. So this power generation system is there in the each individual house owner. Okay, and their own house for the self use. Okay, and they also have the smart meter concept. Okay, so like they have the like this type of understanding. So they have the each individual house have the own solar energy setup. Okay, photovoltaic equipment, and as well as the they have the with this they have the one smart meter concept, which is basically responsible for calculate the what energy is consumed, what is the your available energy, and then can you distribute the energy with the other household user or in the smart grid. So this is the basically whole system. This is known as the distributed trading platform. Okay, and here so we can share the electric energy as well as the data both things. Okay, and whole this architecture is in the distributed in nature because we are using the blockchain concept. Okay, so this is the whole architecture. So we assume that each household user have this solar plate setup, and also they have the smart meter for the reading purpose, and then after that based on their utilization of the energy, generation of the energy, utilization of the energy, finally you transmit or he can request for the some energy for the use. And this is all this thing is in the renewable energy. Okay, and because we concentrate on the renewable energy resources, okay, for the sustainable of our society. So this is our problem statement. The household owner can install the solar photovoltaic power generation system in their own house for self use, and surplus electricity can upload it. Surplus means which is the basically extra. Okay, uploaded to the grid for the financial rebate. So if the surplus energy, initially they consume the some energy because they are using the in the house, they using the fan, ACs, refrigerator, so they consume the energy. So if their role is consumer, but after the consume the energy, whatever the extra, which is the surplus energy, and surplus energy they want to, okay, they want to upload the surplus energy, and this is this surplus energy they for the final rebate they can upload this energy, and then the consumer becoming a prosumers. Okay, so this concept is now the consumer. Previously in general concept wise consume the energy, but here consume as well as the basically upload the energy, so that's why we known as the prosumer. So means producer as well as the consumer both things. Okay, so the characteristic is now different. Okay, so now one challenge is, what is the challenges? We want this thing, it's okay, but what is the challenges if we concentrate on the such type of system where we can utilize the our extra energy thing? So then what is the challenges? Challenges is associated with the the management of a large number of your system as well as the dynamic number of the prosumer. Okay, so this is the basically challenging job. So we concentrate on the not only the 1, 2, 3, we concentrate on the 500, 600 user. So all houses with the solar energy concept or solar energy setup. Okay, so this is the basically challenge. So how we solve this challenge? So what is our objective? Our objective is to design an efficient, safe, fair, and sustainable smart grid system. Okay, which is shared the energy as well as the benefited to the household user. Like he's generated the 500 unit, but he's utilized only 100 unit. So 400 unit he can transmit or he can give to the some of the other user, and then he's received the some rebate and benefit. Okay, this is the whole concept in this case. So what is the problem in the existing grid system is there? So in general the grid system is centralized. Okay, so conventional grid generally uses the centralized management of system which does not scale well, because when we scale the well means large number of the user or like the consumer or prosumer, then automatically degrade the performance of the system because it is centralized control, and it is not suitable for managing the large amount of the consumer. Okay, the cost management and maintenance is also it is problematic for the centralized means conventional centralized management mode. Okay, in addition also to deal with the challenges due to the different standard Okay, as well as the lack of the mutual trust among the participants. So this mutual trust thing also here the very difficulties because these are the independent thing. Okay, so now what is the challenges? Challenges is the what is the challenges? The world is rapidly shifting from the conventional energy sources to the renewable energy, like the sources like the smart grid or like the solar energy based or solar system based smart grid. And here the what is the problem is on the smart grid is required to it's to be the attack of the proof or leak of the information and demand of the centralized system is these are the basically different challenges. Okay, so like the leak of the some information or your what type of means like you want to share the some unit of the information but somehow leak the information. Okay, or you want to request some information, this is under this information. So the security is under important three thing means attack of the proof as well as the leak proof and demand of the central decentralization the system for the energy distribution to provide the transparency of the smart grid system. Okay, so basically what is this challenges is under there is a possibility different types of the attacks or attacker or basically non-licensed user they want to access the your energy or somehow they can utilize the your thing. Okay, but then you are not benefited. Okay, so then second thing is then the centralized control is difficulties, single point of failure. So decentralized thing is required, which is provide the transparency in the smart grid. So this is the benefit. Okay, so then new so new modern energy system facing the difficulties, the challenges. What is the challenges? Large number of devices are connected. Just I mentioned the smart meter, but we can include the multiple devices. Okay, as well as the your single point of failure due to the centralization. So these are the challenges in the current system, and as well as the slow transaction processing because large number of devices. So in the previous lecture I mentioned the create the blocks for individual devices. So your devices is on the 1 million. So then you have to create the 1 million of blocks. So then transaction processing also slow. Then also there is a possibility security attack. So these are the things challenges in the current smart grid systems. Okay, so then what is our contribution? So we want to design the assist the design to the efficient, safe and fair and sustainable smart grid system. So this is our objective. But how we achieve the objective? So in the form of technology. So then here how the blockchain technology we can use the blockchain technology to solve this objective. So then how the blockchain technology has been and can deploy it in the distributed trading platform for the sustainable of our society application, ranging from the energy management to the peer-to-peer trading to then the electric vehicle related application to then as well as the carbon emission trading other things also. Okay, so all these things we have to solve using. So this is our architecture. So what is the possible solution? So possible solution is just I mentioned we can use the same concept. This whole thing is then the distributed and we are using the novel blockchain based security scheme for the secure transaction and for the decentralization for the single point of failure purpose we are using the decentralization as well as we use the transparency. Means one user in the case of like household user can check what are the other user, what is the they have the extra surplus they have or not, or they want to share the some information. So all this information is visible. So that's why the transparent. Okay, but we don't disclose the what is the whose information. Okay, somehow I mentioned this is the grid like the house number 1 or something like that, some identity, not disclose the his confidential information or something like that, or privacy related issue. And so that's why what are the possible solution? Possible solution we can use the public private based blockchain techniques as well as the modification of the internal structure of the blockchain with the consensus algorithm or structure of the blockchain or the leader selection algorithm or smart contract this thing, or we can use the like just mentioned the between the user also the trust management algorithm is important. So we can use some decentralized trust algorithm which is the mutual trust among the participants, then which is benefited if the mutual trust is strong, means their security schemes is the most strong, and we can easily identify this thing. And as well as just I mentioned the reinforcement learning for reward and penalty calculation, like he want to means upload the this thing like the upload the surplus energy. So then he's received the some rebate. Okay, and when you receive the multiple times of the rebate, then somehow he's and receive the some reward type of thing. And when you sometime you also means due to the some problem, you can give the penalty as well. Okay, so we can use the reinforcement machine learning type of concept for the reward and penalty calculation. So here, just to assume that the same thing, but our concept is on the each solar plate have the smart meter, and smart meter is on the calculate the total energy consumption of the individual house. Okay, so this is the whole system we known as, in this whole system, like this type of system, we consider the system known is on the your smart grid NG. Okay, next generation smart grid. So that's why the smart grid NG, the whole system name. And blockchain based protocol, this is the name is on the like the blockchain based security protocol for next generation smart grid transaction. And here in this architecture, in the smart in the case of your smart meter, we are using the one protocol which is named as the grid chain. Okay, so which is responsible for the blockchain block creation. Okay, so whole architecture is named as the smart grid NG, and protocol name is the means smart grid or grid chain. Okay, so here what is our objective? Our objective is a novel blockchain based protocol for security vulnerability in the smart grid. And modern energy system is on the many challenges, just I mentioned. IoT devices adoption, large number of IoT devices want to join to the network, single point of failure due to the decentralized system, slow transaction processing, and emerging cybersecurity threats. Okay, so here just I mentioned we solve this issue. We propose the one protocol for the smart meter. Okay, and smart meter, why the smart meter? Through the smart meter we can perform the transaction. Okay, so we propose the means smart meter is directly connected to the your smart grid. So like here you have the smart meter, and this smart meter is connected to the your smart grid, and this smart meter also connected to the your this solar plate and also your house. And this smart meter is then responsible for the calculate the what power is generated from this plate. Okay, and as well as this equipment, as well as the what type of the utilization in your house. Okay, then all these things is calculated, and inside the smart meter we create the blockchain type of concept, and based on this true value, then the blockchain network this one is create the one block and connected to the all other nodes and create the distributed environment, and also satisfy the all requirement, decentralization, transparency, immutable, all these properties. Okay, so now here so our concept is the whole infrastructure known as the smart grid NG, and inside the smart meter we create the one blockchain based protocol, modified the blockchain which is on the grid chain. Okay, and this scheme is on the secure the transaction and make the energy distribution decentralized, reliable, transparent, and immutable. So our objective is this one. Our objective, this two things is basically provide the secure the transaction, make the energy distribution decentralized, reliable, transparent, and immutable. Okay, and grid chain is it is basically the one concept, modified blockchain technology. Why we modify the blockchain technology? But our objective is increase the number of transaction. Okay, our objective is lightweight execution, because our device in the smart meter, the smart meter is the small device. So in the smart meter, we only include the IoT type of devices for the computation, or IoT type of microcontroller. Okay, so that's why we modified our blockchain protocols. Okay, that is recognize the block network and logical ring topology. So there is inside the blockchain we use the one concept is the logical ring for the structure or when we generate the blocks. Okay, and also we modify the consensus algorithm. Okay, so we modify the two parameter. In the last case, I mentioned that we can modify the multiple parameter like leader selection, structure, consensus algorithm, smart contract. But in this case, only we consider only the logical link topology, which is related to the structure of the blockchain. We change the how in general blockchain block is directly connected, but here logical ring wise they connected, which gives the somehow better performance. So that's why we are using this thing. And consensus algorithm, because we reduce the consensus algorithm, consensus delay. If we reduce the consensus delay, then the number of transactions is in the more, which is important for the smart grid platform. Okay, so now here this is our in general concept. So we have the grid chain, and this is the block creation, and inside the block creation, each block is connected like this way. We can create the logical ring concept. Here we implement the techniques, and here the grid operator, energy service provider, and then the consumer is on the basically the smart meter and smartphone type of concept we can use. So this is the logical ring creation. In general, the blocks are created like this way. Now we add on the extra concept, and this is then the last computer is then the connected to the first like this way. Means we are using the some concept like the leader selection. Through the leader selection, so if the one node is selected as a leader, then he's performed the all transaction of the whole network. Then we completed all the tasks. Then we identify the priority wise next leader. So this type of concept we implemented for the priority wise execute the some tasks, and which gives the high transaction rate as well as the high performance speed. Okay, so this is our whole network. Just I mentioned we have the two concepts. One is on the smart grid, NG is on the whole system, and grid chain is the protocol. Grid chain is on the protocol here we implemented. Okay, using the concept of the logical ring, and we modified the consensus algorithm as well as modified this structure of the chain. And here this whole architecture is on the based on the your either I mentioned the smart meter, or we can include the some app into the smartphone as well for the reading purpose or something. Okay, so this is the whole system of this architecture. And then we implement, we assume like here the smart meter means it is the IoT type of devices. Okay, so IoT type of devices. So here in this figure, this is the grid operator and generate the power. Okay, so then based on this concept, the distribution, all these things, okay, they also individually generate the power and distribute all these things and create the blockchain network. Okay, and whole system is known as your smart grid NG model. Okay, and we assume these things and like in the smart meter, we have the lightweight type of the devices like Raspberry Pi. So we implemented our both things. One is the smart grid NG as well as the means your grid chain into the Raspberry Pi as well as the desktop. Okay, and we check what is done. We using the Java platform for implementation. Okay, so first we check the consensus delay thing. So this is our grid chain, because consensus delay means we modified the blockchain. Okay, so in the grid chain means we modified the structure of your block and also the your consensus algorithm. So consensus, when we modify the consensus algorithm, so we modify somehow reduce the delay consensus time. Okay, so consensus time is and the delay is and the less in our case compared to the traditional approaches, whatever approaches available for the smart grid. And as well as they are not using the concept of the prosumer. They are using all this existing scheme. They are using the concept of the consumer type of concept. So here in our case, extra features we consider the prosumer type of thing, which is benefited to that. And if they reduce this thing, okay, consensus delay, so automatically enhance your transaction frequency, as well as we also create this logical ring type of concept with the priority wise select the leader, in general randomly select the leader. So that's why it gives the priority one is task to complete the task. So that's why this will provide the large number of transaction per second, because our consensus delay is also low, as well as we check modify the structure. Okay, and these are basically block congestion. So based on all existing approach, we also check in our case block the congestion so we control the block congestion control. Okay, we consider some parameters and block congestion. Okay, so in the case of blockchain, when the congestion will occur in the large number of, consider some scenario. Now in the security point of view, executed the means individual security algorithm. We implemented all this algorithm. Those security algorithm is suitable for the smart grid transaction. We implemented the algorithm in the two platform. One is in the desktop as well as in the Raspberry Pi. Okay, because desktop is in general is not possible for the smart grid, because the smart meter. Then if you include the this is the one desktop cost also, as well as the setup also very difficult. So consider the Raspberry Pi, and here we cost for the individual all this type of the security which is basically provided to the smart grid, then execution cost of all these. Okay, what is total